Here is a technical overview of A2A packets and data security. An A2A message starts as a simple JSON object. To travel across a network, it gets wrapped in layers of headers, like a letter being put into an envelope, then put into a shipping box. The app data is layer 7. It contains the JSON payload. Then the TCP segment is contained in layer 4. The IP packet in layer 3, then the Ethernet frame header in layer 2. This model simplifies things by omitting TLS encryption, which we will go into later. The data density of the packet is displayed below. Each layer increases in size with the associated characters sent in the JSON payload. As you can see, the smaller the payload, the less efficient the total packet to actual data is sent. This is because padding and data architecture revolves around powers of 2 for efficiency. The payload efficiency tells us how much of a network packet is actually useful information. By simulating different packets over different network conditions, we can see how modifying the size modifies the transmission time. Let's look at a 21-agent orchestration that simulates a complex market analysis using 20 agents and 1 orchestrator agent. Now let's use sample payload sizes and test the latency and total data transmitted. The A2A protocol uses proven industry-standard layers to provide security, since TCP does not provide security, only reliable data delivery. The A2A application layer handles authentication and authorization by determining who and what each agent is allowed to do, such as handling API keys, OAuth certificates, and are declared in the agent card. The TLS/SSL security layer provides confidentiality and integrity by encrypting the data to prevent eavesdropping and ensures it hasn't been tampered with in transit. This turns HTTP into HTTPS. TCP, or the transport layer, ensures that all the packets of a message arrive in the correct order without errors. It provides a reliable connection, but no encryption. The TLS handshake secures the channel before any A2A data is sent. The A2A client and server perform a TLS handshake, which uses a public key cryptography to establish a secure encrypted channel. A client hello is sent that informs the server the encryption methods known. The server replies with a certificate to authenticate itself to the agent. The client checks the server's certificate with a trusted authority and verifies its identity to prevent packet interception. The client and server then securely exchange a session key. This will be used to encrypt all future data. A further breakdown is shown. The application-level authentication defined in the agent card is shown. Step 1 shows the client fetches the public agent card and sees it requires bearer token authentication. Step 2 shows the client getting an OAuth token and making a request. The A2A server receives this request, decrypts it, inspects the authorization header, validates the request, and processes the JSON payload. Let's go over how this would look in a terminal. We construct the payload, add the authentication header, encrypt the HTTP request, and send over the web framework. The A2A server decrypts and validates. An animation of the process is provided. Be sure to check out the GitHub listed in the description for the full interactive tutorial. You can load the files directly into Google Gemini or another AI to customize and modify the tutorial as well.